Good morning, geometry students. Good morning, geometry honor students. So this one is for 3.1 and 3.2 for the lecture of parallel lines and also the angles relationship. Okay, so now let's look at that some of the warm-up problem here. So identifying each of the following. Okay, let me go through the slide like this. So point that lines in the same plane. Okay, so they're called the coplanar point. Two angles whose sum is 180-degree, supplementary angle. The intersection of two distinct intersecting lines, then that'll be a point. And a pair of adjacent angle whose non-common sides are opposite rays, so then that'll be linear pair. Okay, so now objective, identifying parallel, perpendicular, and the skew lines, identifying the angles formed by two lines and a transversal. Here's some of the vocabulary. Parallel line, perpendicular line, skew lines, parallel plane, transversal, corresponding angle, alternate interior angle, alternate exterior angle, same side interior angle. You know, some of those you guys probably have seen that before, like the transversal, corresponding, alternate interior, alternate exterior, or the same side interior, something that you learned from pre-algebra. And also for the parallel line, perpendicular line as well. So now check it out. So parallel lines are coplanar and do not intersect. So in this figure, so in this perfect cube here, as you can see that AB is parallel to EF. They never intersect. It's on the same plane of plane AB, EF. And also EG, okay, so EG is parallel to FH. Okay, so again, it's right in the front surface right here. The plane EF, HG. Okay, so two lines are parallel and they never intersect. And also sometimes you'll see the arrow. So the arrow like this, that means it's showing the line segments or the lines are parallel. So perpendicular line, the upside down T, it's always the symbol representing perpendicular lines. So intersect at 90-degree angle. In the figure AB, it's perpendicular to AE. So AB right here, it's perpendicular to AE. And also the little square symbol, it shows that they're perpendicular. EG is perpendicular to GH. Okay, so EG is perpendicular to GH. So skew lines that are not coplanar, so they're not on the same plane. And skew line is that they're never intersect, and also they're not parallel. So in the figure, AB and EG are skew. So line AB, EG, well, because this one comes from the upper plane, and then EG, it's right on the front plane right here, and they're never intersect, and also they're not parallel. So parallel planes are planes that do not intersect. So in this figure, so plane ABE, it's parallel to plane CDG. So if that's a perfect cube, we do have three pairs or parallel plane. So the upper plane, the bottom plane, the left, the right, and also the front, and then the one on the back. So once again, the arrows are used to show that line AB is parallel to EF, and then EG is parallel to FH. So just the indicator showing that lines are parallel, or the line segments are parallel. So segments of ray are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. Okay. So here's another example, quite similar to the perfect cube. It's a rectangular prism. So a pair of parallel planes, so just name the following. So it could be LM is parallel to QR. Okay, LM parallel to QR. Okay. A pair of skew segments, KN and PQ. Okay, so KN and PQ. Okay, so KN, which is the one right here, and then PQ, the bottom one. And then a pair of perpendicular segment, so the one that shows the 90-degree symbol, the square symbol. So NS is perpendicular to SP, or it could be NS is perpendicular to SR. A pair of parallel plane. So plane NMR, it's parallel to plane KLQ. So NMR. So the front plane right here, and then KLQ, the one on the back. So here's another example, so you can find out that the parallel segments, the parallel segment and the skew segments, and also the perpendicular segments, and also the parallel plane. Okay, so now let's talk about the transversal. A transversal, it's a line that intersects two coplanar lines at two different points. And the transversal T and the other two lines, R and S, form A angles. Okay? So as you can see that the lines, if those two lines, well, they are formed, so, and also the transversal going through those two lines. So as you can see that we do have those angles. So pretend that this line R and line S, they're parallel. So we do have 4 exterior angles and 4 interior angles. So the exterior angle, we got 1, 2, 7, and 8. Interior angle, we got 3, 4, 5, and 6. So corresponding angles that lines in the same size of the transversal T on the same size of line R and S. So like angle 1, angle 5. So anytime that you have the corresponding angles, so that means those angles are congruent and also they're facing to the same direction. Okay, so facing to the same directions. Alternate interior angles. So alternate interior angle, that means it's bounded in between those two lines. And then they're facing opposite of each other, like angle 3 and 6 or angle 4 and 5. And then alternate exterior angles. So lines on the opposite sides of the transversal T outside the line R and S. Again, the key word exterior, outside the lines. So alternate, again, the one that it's sitting outside of those two lines there, and they're facing opposite of each other, like angle 1 and 8, 2 and 7. Same side interior or consecutive interior angles, lines on the same sides of the transversal T between line R and S, like angle 3 and 5. So normally, if those two lines are parallel, so the alternate, the same side interior angle, they're always adding up to 180 degree. So like 3 and 5, so once you combine them, it will be 180 degree. And 4 and 6, also 180, if these two lines are parallel. Okay, so now check it out. So corresponding angles, so we do have angle 1, angle 5. Alternate interior angles, so we do have angle 3 and 5. Okay, so facing opposite of each other inside those two lines throughout the transversal. Alternate exterior angle, so then that'd be angle 1, angle 7, or angle 2 and angle 8. Same side interior angle, so 4 and 5, or 3 and 6. Okay, so here's more example that you guys can practice. Okay, so identify a transversal and classify each angle pair. So angle 1 and 3, so the transversal would be line L. So as you can see that angle 1, angle 3, so they're facing to the same directions, facing down this way, so they're considered corresponding. And then angle 2, angle 6. So the transversal will be line N, because that's the common line going through those two, line L, line M. And this one, it's being bounded inside those two lines, so it's alternate interior angle. Angle 4 and 6. Okay, so 4 and 6, transversal will be M. And this one, they're all sitting outside those two lines, L and N. Okay, so more practice, so similar to what we're doing. So here's some of the practice problem you guys can go through, similar to what we were doing. So identifying the parallel segments, skew segments, perpendicular segments, and the parallel plane. And also identifying each one of the following: one pair of alternate interior angle. So things that's such as what? EHG. Okay, so EHG. And then angle HGK. So those two angles right here. And then one pair of corresponding angle. So EHG, FGJ. One pair of alternate exterior angle. So IHE, JGK. One pair of same side interior angle. Okay, so EHG and angle HGF. So check this out. So this one you guys can always, come up with the solutions. So lines are parallel, So there's so many different type of corresponding angle. exterior, alternate interior, and the same side interior. Okay, so thank you for watching the video today. So again, if you guys do like this video, so please subscribe to the channel so there's more valuable lessons coming up. And I'll see you guys next time. Take care.